Okay, this time we're measuring current in a circuit, and I'm going to show you two methods. There's a method for when you don't know what the current is and when it's a higher current, up to 10 amps on this meter, because you can see this meter has a socket for 10 amps. So we're actually going to plug it into there first, because if you don't know what the current is going to be, it's better to go there. Because if it's higher than, according to this, the 200 milliamp range, which is the lowest or the highest milliamp range, it will blow the fuse, because a multimeter will have a fuse to protect it for the more delicate circuitry for the lower current readings. So the 10 amp range, we go there first to check it. Remember, you always measure in series when you're measuring current in a circuit. So what we would have to do is actually break the circuit so that the light no longer goes, and we have to stick the meter into, let's put it on that side so you can see, the meter has to go into the place of that thing that I pulled out, the piece of wire. So when I put that in place like that, the light goes back on, and we don't get a reading in this case, which tells us that the current coming through is much lower than the 10 amp range will allow for. Oh, in fact, I've done something obviously wrong. I haven't even clicked it onto the 10 amp range, so let's go and have a look at that. We might get a little reading. We get a tiny little, it just goes 0.01. Does that show up on your screen? I think it does. So we're going to go switch over to the milliamp range. V omega milliamps tells us it's a milliamp range. And we click up to the largest milliamp range, because you always start from the top one, work your way down. And we're getting a reading of 18.4 milliamps. That's pretty good. I'm just going to step down to the next range, 20 milliamp range. So 18.4 is still under 20 milliamps. And that's going to give us an extra significant figure, 18.46, 18.45. Okay, if I went down to the next range, the 2 milliamp range, we should get a nonsense reading because it's too large to be read on that range. Okay, so we'd go back to the 20 milliamp range. That's our best reading. There we go. Now, if I was to try and measure the current by connecting in, say, across like this, I'll do this, you won't see anything. Well, you do see a little jump, but that's definitely not the same reading. Okay, that's short-circuiting this connection and making the electricity come through the meter. I'm going to do something a little bit possibly dodgy that might blow my my fuse in this meter. In fact, I put on the 10 amp range to do that so it doesn't blow the fuse. If you're measuring current and you try to connect in parallel the way you would with voltage, watch what happens to the LED. It goes out. Okay, so now we're short-circuiting it, and we're not actually getting the current reading that we should get. There's a little 0.01 on the screen, but this is misleading. We have to measure it in the correct range. Okay, milliamps for this one, because we've already done that and I know it. And you have to connect the circuit using the meter, so it has to be in series. Okay, just while we're here, I'll show you a voltage reading as well. So we're still in the right socket for that. We want to go on to the 20 volt range, because I know this is maximum, it's about 9 volt battery, so it should be able to read fine for there. We can measure the voltage of the supply there on this. When it's connected to the circuit is 8.05. We can measure the voltage across the LED, 2.16 volts. We can measure the voltage across a small resistor just here is 5.85. And the voltage here plus the voltage here should add up to the voltage of the supply, and it does, which is really nice. Okay, I'm going to disconnect the circuit now, and I want to show you one other little feature really quickly before we get too far ahead. This is continuity, or measuring whether a circuit is complete or not. And what you do is you have it set onto, you've got this little setting here, which says diode symbol, and it's got a little, looks like a Wi-Fi symbol if you put it up that way. Whoops, up that way, but it's actually a speaker or a sound kind of a symbol saying that there's a noise, and I'll show you why there is noise. When you push that together, it beeps. Can you hear that? That beep tells me that it's electrically conductive. If I take this, which I know conducts electricity, and I touch it, it beeps. If I take something that I know does not conduct, like the cord on my lanyard, and I connect one there and one there. Okay, I don't know if you can see that. Here we go. And it beeps. It doesn't beep, I should say. So that tells me it doesn't conduct. So this is good for finding faults in a circuit, especially if, like, you might have something not quite connected properly, and I've not quite connected this properly to make the LED not go. I can see, put the probe at one point there, and just beep, beep, beep. When I get to here, there wasn't a beep. So now I know I have to connect that properly, and then it should beep. There we go. So everything beeps nicely. That means it should run fine, and it does. There it is running. Okay. The other little thing is, because this is actually used for testing diodes specifically, I might be able to test my LED with this. We'll give it a try. When you put that across there, no, it's too big for this. It needs a proper diode. It actually measures the millivolts for the voltage drop across the diode, which is a handy little thing. But, yeah. And multimeter care, why not? We'll give you a quick start on that. Make sure you turn it off to preserve the life of the battery, and it's a good idea to protect your cords by wrapping them around the meter. And did you notice that I turned the whoops, back down here so you can see. I turned the ends of the probes where the wires come out into the same direction that the wire is going through. So rather than doing it this way and bending it back that way or bending it that way, it creates a sharp, I'll keep moving it up, rather than doing it that way or that way, it creates a very sharp bend just here. So I turned it around and I turned this around so they've got the support of the meter, and then I've wrapped them around like this. And that's just a really good way to preserve your the probe cables so that they don't break. Okay, so good to have your multimeter care, and also don't drop it. Make sure it's got a protective fuse, and change the battery if it shows up the battery warning. So that's a multimeter. There you go.